A runner going 2 meters per second trips and falls, hitting the ground with an impulse of 16 newtons times seconds. What is the mass of the person? So I'm going to write down everything that they gave me. They gave me a velocity of 2 meters per second. So that's an initial velocity. And the final velocity for that person is going to be 0 because they fell and hit the ground. Next, we have an impulse of 16 newtons times seconds. And we're trying to find the mass of the person. So I'm going to use the equation, the change in momentum equals the impulse. And this can be represented in variables by delta P equals J. And so the change of momentum, delta P equals mass times the change in velocity. So we're going to put this in for delta P here. So it's going to be mass times the change in velocity equals the impulse. Now we need to get mass by itself. So I'm going to divide both sides by the change in velocity so that these cancel out. And my equation will now be mass equals impulse over the change in velocity. And after that, I just plug everything in. So it will be 16 newtons times seconds divided by, and it's going to be, so the change in velocity is the final velocity minus the initial velocity. So it's going to be 0 minus 2, which equals 8 kilograms. Now notice how this isn't positive or negative, and that's because mass is a scalar quantity. So it doesn't have a direction. It can't be positive or negative. So it's just going to be 8 kilograms. And it comes out to kilograms because down here this is really meters per second. And that N stands for kilograms times meters per second squared. And so whenever all the units cancel out together, you're left with kilograms. So that's the final answer.